Welcome to Kinematics Part 3. Today I will be talking about reference frames. So in this video, we're diving into reference frames. So first of all, we need to ask ourselves, why are reference frames so important? Well, when discussing an object's motion, like its velocity, you always need to compare it to something, which is the reference frame. For instance, if you say a car, for example, is moving 30 miles per hour relative to the ground, then your reference frame would be the ground, the thing you are comparing, which is the ground. If the thing about reference frames, if a question never specifies what the reference frame is, then typically it would be the ground that you're referring to as the reference frame. So another example of a reference frame would be, let's say, a car, okay? Let's say this car, you say the car is relative to, a car going 30 miles per hour is also relative to this bus right here. Okay? You saying that the bus is relative to this car makes this bus your reference frame. So let's give another example. Okay? Let's say we have someone, just imagine someone named John. Okay, this is John. Okay? John is a very happy man. And he's moving 2 miles per hour. Okay? In the right. In this case, since I mentioned how if the question never mentions what the reference frame is, the ground is the reference frame at default. So in this case, John's reference frame is the ground. So yeah, this is simple enough. So now let's add another person. Now let's say Sally. This is Sally, okay? Sally is actually moving faster than John, going at 5 miles per hour, okay? Relative to the ground. Just means like relative to the ground. So John relative to the ground. And then Sally relative to the ground. So here's a question. What is Sally's velocity relative to John? Also, Sally is also moving right, by the way. So what is Sally's what is Sally's velocity relative to John? So because Sally is moving faster than John, every hour she's moving 3 miles ahead of him. So this would mean Sally's velocity relative to John is 3 miles per hour greater than John's velocity relative to the ground. So relative to John's velocity, Sally is moving 3 miles per hour greater than John. Now let's flip the perspective a bit. What's John's velocity relative to Sally? Since John is moving slower than Sally, moving 2 miles per hour, from Sally's viewpoint, it seems like John is moving away from her. Thus, John's relative to John's velocity relative to Sally is negative 3 miles per hour. In this case, depending on which perspective we're looking from, John's or Sally's, the reference frames change accordingly. So this basically just illustrates how reference frames plays a vital role in understanding motion from different perspectives. Here we can see that Sally is moving 3 miles per hour in comparison to John as the reference frame. But in John's case, John's velocity compared to Sally's is 3 miles per hour less than Sally's velocity.